None of us can imagine our lives without fan, bulb, computer, refrigerator, etc. All these objects work because of electricity. So, electricity plays an important role in our day-to-day life. It lights, heats, and cools our homes and performs many other routine jobs for us. Electricity flows through electric wires. Electricity in motion is called current electricity. Sources of electric current. Sources of current can be divided into two types: small sources of current, bigger sources of current. Cells are small source of current. In a cell, chemical energy is converted into electrical energy. A cell basically consists of two terminals, a metal cap on one side and a metal disc on other side. The metal cap is the positive terminal and the metal disc works as a negative terminal. The chemicals stored in the cell produce electricity. Cells are of two kinds: primary cells and secondary cells or accumulators. Primary cells. These cells provide current as a result of the chemical reaction that takes place in the chemicals stored in them. Chemical reaction taking place in a primary cell is irreversible. That is, once the chemicals are used, primary cell stops producing electricity. Hence, primary cells cannot be recharged. Examples of primary cells are simple voltaic cell, Daniell cell, dry cell, etc. Secondary cells or accumulators. Secondary cells also provide current as a result of chemical reaction taking place in the chemicals stored in them. Chemical reaction taking place in a secondary cell is reversible, so it can be recharged and hence it is better than the primary cell. Lead accumulator, alkali accumulator are examples of secondary cells. The parts of secondary cells are lead oxide, insulating case, gas events, sulfuric acid, and two terminals, positive and negative. Electric circuit. The closed conducting path in which the electric current flows is called an electric circuit. An electric circuit constitutes of a source of electric current, cells, etc., a conducting wire, an electrical appliance, bulbs, etc., a switch or key. When the switch is closed, the circuit is said to be closed circuit. In this condition, current flows and appliance works. Example, the bulb glows. However, the circuit is said to be open circuit when switch is open and there is no flow of current. Take a lemon. Roll it to soften the skin, but be careful not to break it. Insert the safety pin and the board pin into the fruit about 5 cm apart. These should not go through the button skin of the fruit. Twist the wires around safety pin and board clip. Now connect the open ends of wires around the switch and bulb. Put on switch. The bulb glows. Bulb. It produces light and is represented by coiled wire inside the circle as shown. Connecting wire. The connecting wire is represented by a straight line. It is usually made of copper and provided with insulation. Plug key. A plug key is an electric switch. It is shown in both on and off positions in figure. Cell. A thin long line represent the plus terminal and thick short line the negative terminal as shown. Battery. A combination of two or more cells is called battery. Its symbol is also a combination of cells symbol as shown. Fuse. It is safety device in electric circuits. The components such as cells, bulbs, wires, etc. are called elements of an electrical circuit. The various components of the circuit are represented by standard circuit symbols. It is much easier to draw a circuit diagram using symbols. Therefore, we generally represent an electric circuit by its circuit diagram as shown. Symbols of some common components are shown. Electric switch. An electric switch is an arrangement used for completing and breaking the circuit. When switch is in open position, the circuit is incomplete and hence current does not flow through it. When switch is in closed position, the circuit is complete and hence current flows through it. In our house, there is a main switch to which all the connections are made. If the main switch is turned off, then all the other appliances also get turned off. Hence, circuit breaks and no current flows through it. Electric conductors and insulators. Electric conductors are those substances which allow electric current to pass through them. For example, metal wire, sewing needle, metallic key, etc. Insulators are those substances which do not allow electric current to pass through them. For example, wood, plastic, rubber band, etc. Conduction tester is used to find whether substances are conductors or insulators. Pliers and screwdrivers have plastic coating or rubber handles so that the electrician working with them does not catch current because plastic is a good insulator. Similarly, an electrician wears gloves which are made of insulating material while working with high voltage so that he does not get an electric shock.